Hello everyone, it's Red Saber here from Saber C++, and today we're going to be learning about how to use displays with Arduino. Today we'll be looking at showing text and changing the background color. But if you want to use the touchscreen on here, then you can check out my next video, which I'll link to in the description once it's ready. Also, don't worry if you have a slightly different one than this, as the code we'll be using works for most of the Arduino compatible touchscreens that are available. I've put a couple of links in the description so you can pick up a screen if you need one. The first link is for this exact one from Adafruit, but I recommend the second one if you have an Arduino Uno because it just snaps on and you don't have to worry about the wiring at all. The resolution for either one is 480 by 320, which is quite high for something you can get for only 20 to 40 bucks. Let's get started. This is our display. Now the main feature of course is the big screen here, but we also have two sets of pins. Now this one is for 8-bit communication and this one is for SPI communication, which is what we'll be using. There's also a micro SD card slot, but that's for storing images. We won't be covering displaying images in this video, but if you'd like to see that in a future video, let me know in the comments. First, I'm going to slot my display into this breadboard so that I can connect the wires to it more easily. We will be using SPI communication, so we need to make sure that it's not the side that has D0 through D8, but it's the other side, which has all these pins labeled with different letters and whatnot. Of course, the first thing we'll need to do is provide power to the display. So I'll connect a yellow wire from the V in, which is the second one here, to the 5-volt port on the Arduino. And I'll connect this white wire from one of the ground ports on the Arduino to one of the ground ports on the display. Now there's one here, and there's also one here in the middle. Now if we power up our Arduino, we'll be able to see the backlight light up, so we can tell our display is working. Before we wire up the communication pins, we'll need to tell the display that we'll be using SPI communication. So we'll run a wire from this 3V3 pin, which is sending 3.3 volts out constantly, to the IM2 pin. This tells the display that we'll be using SPI communication, so it doesn't expect 8-bit communication from this side. There we go. Now what we'll be doing is we'll be wiring all of the pins from CLK to D/C to pins 13 to 9. So I'll connect the CLK pin to port 13, and I'll connect the MISO pin to port 12, then the MOSI pin to port 11, then the CS pin to port 10, and lastly, the D/C pin to port 9. Now, these first three pins, CLK, MISO, and MOSI, are forced to be 13, 12, and 11 because that's the way the Arduino is wired internally. However, the last two, the CS and the DC, we could actually change to any of the other pins. They don't have to be 9 and 10. We'll be able to adjust that in the code if we want. However, to make it easier, I'm just going to use all of the pins from 13 down to 9. And there we go. I'll double check that all of these wires are in the correct order on both sides, and then we'll hop over to the computer and write our program. For this program, we'll actually need two libraries. First, let's open up the Library Manager tab, which is signified by this books icon over here. Then we can search for the libraries we need with this bar up here. The first library we need is called the Adafruit GFX library. It automatically selects the latest version, so we can simply click this install button and make sure to click install all so that it'll automatically install any dependencies. In this case, it has a dependency of the library Adafruit bus.io. So if we didn't install that, some of the things might break. The other library we need is called the Adafruit HX 8357 library. As you can see, it popped up as we started typing the name. So once again, we can simply click the install button and install all of the dependencies as well. The first thing we'll do is include the libraries we need. We'll start by including the SPI.h library, which we didn't need to download because it's included by default with the Arduino IDE. Then we'll include the Adafruit GFX library by including Adafruit_GFX.h. And the other library we downloaded by including Adafruit_HX8357.h. We'll also need to define two constants for the variable ports that we assign, the CS port and the DC. If you remember, the CS port was 10 and the DC port was 9. The last thing we'll need is an object that will represent our display. It'll be of type Adafruit_HX8357, and we'll call it TFT. We'll initialize it using the constructor for the Adafruit HX8357 object and passing in two variables for the two variable ports, the CS port and the DC port, which we just declared two constants for. In the setup function, we'll initialize the screen using the tft.begin function. We can fill in the background using the tft.fillScreen function and passing in a color. The libraries we've included contain all of the most common colors in the format HX8357 underscore and then the name of the color in all caps. For example, red, like this. We also need to set the rotation of the display. Now, by default, it's in a sort of portrait orientation with this left side as the top and this right side as the bottom. However, I'd like it to be in a landscape orientation like I've laid it out here. So we'll need to use the set rotation function to set the rotation of it to 1. 0, of course, is the default portrait orientation. 2 would be upside down portrait orientation, and 3 would be upside down landscape orientation. Before we can type anything, we'll need to set up the text. First, we'll set the cursor location. I'll just set it to 0, 0, which is the top left corner of the screen. Then we can set the color of the text using the setTextColor function. I'll set mine to the preset for black. Then we can set the size of the text. Size 1 means that the text will be 6 pixels wide and 8 pixels tall. Size 2 is double that, 12 pixels wide and 16 pixels tall, and so on. I'll set it to 5 so we can have some nice large letters. After all of this text setup is done, we can use the tft.println function to actually print out the text that we want to show. I'll just print out hello world with an exclamation point, but you can print out whatever you want. Let's make sure our board is connected and upload our code. And there we go. Now our display is printing out hello world in nice large black letters on our red background. Let's try changing up the colors and maybe printing a bit more text. Before we do, if this video has been helpful to you so far, please tap the like button so I can keep creating more. First, let's change the background color to black and the text color to white. Then, let's set the text size down to 2. And then, let's adjust the cursor position so that the text is centered. The first thing we'll need to do is get the position of the center of the screen. So since the width is 480, the x position should be 480 divided by 2. And since the height is 320, the y position should be 320 divided by 2. This won't actually put our text in the center where we want it to be. Instead, we need to figure out the length of the text in pixels and then subtract half of that, so that half of the text is before the center position and half of it is after. And the same thing with the height. So for the width, we'll do 420 divided by 2 to get the center, and then we'll subtract the length of the text, being the number of characters, which is 12, times the width of the text, each character is 12 pixels wide, divided by 2. So the length of the text in pixels is 12 times 12, which is 144, and since we only want half of that to be before the center, we'll divide it by 2. For the height, it's a bit simpler. We can simply subtract half of the height of each character. Since the characters are 16 tall, we can subtract 16 divided by 2. So the top half of each character is above the center point, and the bottom half is below. Let's upload our code and see how it works. And there we go. Now our text is perfectly centered in the middle of the screen. Now, this display actually also has a resistive touch screen, which means that it can detect finger presses anywhere on it. If you'd like to learn about that, check out my next video, which I'll link to in the description as soon as it's ready. If you'd like to learn about some other Arduino sensors and modules, check out my channel, Saber C++. Thanks for watching.